All right, so today we're going to look at 1.6. Okay, section 1.6 is on angle pair relationships. Okay, so the idea here is we're going to be looking at not just a single angle, but when we have two angles, what are some relationships we can have? You probably already know some, like complementary, supplementary. That's a relationship between a pair of angles. All right. One thing we're going to look at is what's called vertical angles. Okay, we're going to see vertical angles a lot. This situation will come up a lot throughout the year. Two angles are vertical angles if their sides form two pairs of opposite rays. Okay, so two angles are vertical angles if their sides form two pairs of opposite rays. Okay. There's a picture of some vertical angles. Let's focus on the first example, 1 and 3. Let's say this is angle 1. Just draw it in a different color so you can see it. This is angle 3, okay, in blue. Angle 1 and 3 would be considered vertical angles, okay, because the sides of the angles form opposite rays. Okay, you have an opposite ray that's in red and blue, pointing in opposite directions, and you have another one in red and blue, pointing in opposite directions. So basically the shape you get is an X. That's what vertical angles look like. Okay, so 1 and 3 are vertical angles. And let me do it as 2 and 4. Okay, so if I color it that way, here's 2. And here's 4. Now again, we have two pairs of opposite rays. If you look at angle 2 and angle 4, or angle 1 and angle 3, does anybody notice anything about them? Do they kind of look, I'm looking for something here, yeah?
They are the same degree, so they can
Right, they have the same measure, okay, which we'll get to right here. Okay, so this is a theorem. Vertical angles are congruent. Vertical angles are congruent. Now, this is a theorem. What does that mean? This isn't a postulate. That's different. This is a theorem. Yeah?
We take it for, like, we don't prove it right or wrong. We know it's right. But
With a postulate, we assume that it's right.
oh, so we could prove that
Right.
it's right or wrong.
Right. This is a theorem. Theorems have to be proven. Okay. In this section, we're not going to get into proving it, but we will prove this in chapter 2. Okay. There's a mathematical way to prove that vertical angles will always be congruent. And before we can start using this fact in chapter 2, we'll prove it. That's a big part of geometry. You have to prove things. That's more so than you had to do in like algebra or even next year when you take algebra 2. Geometry has more proofs in it. Okay, here's another fact. Okay, another term about a linear pair. Okay, what that means. If we have two angles that are adjacent. Okay, remember angles are adjacent if they have the same vertex and they share a side, but they don't share any interior points. Angles 1 and 2 in that picture are adjacent. Angles 2 and 3 are adjacent. Angles 3 and 4 are also adjacent. there's some example, and 1 and 4 is adjacent. Okay, so two adjacent angles form a linear pair if the side that they don't have in common, okay, because to be adjacent, they have to have one side in common, but if the side that they don't have in common forms opposite rays. Okay, here's an example. Angles 5 and 6 are a linear pair. Okay, how do we know? Well, ray BD is the side they share. Ray BA and ray BC, that's the side they don't share. But the side they don't share forms opposite rays. Okay? BA and BC point in opposite directions. So we call these two angles a linear pair. Does anybody notice anything about angle 5 and 6? Because their non-common side forms opposite rays. What do you think that these angles would add up to if you add 5 and 6 together? Yeah?
180.
180. Okay? That's a fact that results from being a linear pair. Okay? It's not the definition of a linear pair, but it's a fact that is a result of it.
Also a theorem.
Is it a theorem? Yeah, that is something we could prove. We could prove that if two angles form a linear pair, then they add up to 180 degrees. Yep. I don't know if we're going to state that formally as a theorem today. We might, we'll see. But it is something we'd have to prove. Okay, so this is what I just explained. BD is the common side to each angle. BA and BC point in opposite directions. That makes angles 5 and 6 not only adjacent, but a linear pair. Okay, so we are going to state it today, but I don't think we're going to prove everything we do today. I'm not going to prove the vertical angles, but maybe we'll try to prove this one. Let's see. Okay, so if two angles form a linear pair, then they add up to 180 degrees. Okay, you know what? Since we have a little bit of time, why don't we do one proof? Okay, I don't think you're going to find the proof in this section. Okay, they don't do it until chapter 2, but we got a little time, so let's look at one. Okay. Let's do the one that's vertical angles are congruent. Okay, I wasn't going to do it, but let's do it. Okay, when you do a proof, there's different kinds of proofs you can write. Okay, the proof that we write most of the time in this class is called a statement reason proof. A statement reason proof is set up in two columns. Statements on the left, reasons on the right. So every time you make a statement about something on the left, you have to give a reason why you made that statement on the right. Okay? And the reasons are things that are we're going to learn as we go. So as the course goes on, you're going to learn more and more and more reasons. Right now, we don't have a lot of reasons yet, which makes the proof easier. Okay? So to prove that these are vertical angles, I'm going to go through this proof with you. Okay? To prove that vertical angles are congruent. First thing I'm going to do is I'm going to state what was given to me. Okay, a lot of times that's what you do first. Not always, but a lot of the time, you're going to just write down what was given to you. Okay? Angles 1 and 3 are vertical angles. Okay? How do I know that? Well, back in the diagram, that was given to me. Okay? So that's the reason. It's given. Okay, the next statement we could say are 2 and 4 are also vertical angles. What's the reason for that? That was also given to me. Way back in the original diagram. Okay, so we're using this top diagram here. 2 and 4 are vertical angles. Okay, so now The next step says angles 1 and 2 form a linear pair. Now that's not given to me. I've already said everything that was given to me in step 1. How do I know 1 and 2 form a linear pair? Well, I look at the diagram, and I can see that angles 1 and 2 have a common side, and then their non-common side forms opposite rays. Well, by the definition of a linear pair, angles 1 and 2 are a linear pair. So that's why I can say that statement. Okay, so angles 1 and 2 form a linear pair, and that's the definition of a linear pair. A lot of times, the reason that you use, it can be a definition. Okay, let's look at our next statement. Next, I've said that angle 1 plus angle 2 equals 180. Okay? That's a fact that results from being a linear pair. Okay? I wrote definition of linear pair. Some teachers are more or less picky about the reasons you write here. I'm okay with that. Okay, your book might write this step a little differently, but I think that's fine. Okay? Now we have to fill in the rest of the steps. I started you guys off with the first 3. Let's see if we can there might be 2 or 3 more steps to prove this. Let's go back up and look at our diagram. Okay, we know 1 and 2 form a linear pair. Is there anything else there that forms a linear pair? And keep in mind, I'm trying to prove something about angles 1 and 3. That's my goal. So I know 1 and 2 are a linear pair. Anything else?
Would it be 4 and 3 and 4 and 1 and 2 and 3? Linear
But we only need one of those. I need the one that's going to have to do with the angles that I want to prove something about. And it'd be nice if it shared something in common with the 2 angles I already used. So 1 and 2 are a linear pair, and
4 and 3.
4 and 3, but I didn't use 4 the first time. So that's not going to help.
So
2 and 3, that's going to help. Okay? We're going to say 2 and 3 are a linear pair. Okay, so step 4. Angle 2 and angle 3 form a linear pair. Okay, what's the reason why I can say that? Why can I say 2 and 3 form a linear pair? Yeah?
I don't know. It's the definition of a linear pair.
Yeah, by the definition, if you look at the opposite rays, they form, the non-common sides form opposite rays. So that's the definition of linear pair. And as a direct result from that, what do we know about angle 2 plus angle 3? Their measures add up to, yeah?
180.
They add up to 180. Now, I know technically we're supposed to put the letter M here, but I'm okay if you write it like that. Angle 2 plus angle 3 adds up to 180. And again, that's part of what I'm calling the definition. It's a fact that's a result of it. Okay. Now, anybody see anything I can do here? It's going to be something involving step 3 and step 5 and kind of combining them together. Angle 1 plus angle 2 equals 180. Angle 2 plus angle 3 equals 180. So that means something else if we put those together now. Yeah?
It equals, if you add those 2 together, they equal 360.
Okay, if we add 1 plus 2 and 2 plus 3 together, we get 360. Or what can we just say if we compare the sum of angles 1 and 2 to the sum of angles 2 and 3? Yeah.
They're equal.
They're equal. So now we can say angle 1 plus angle 2 equals angle 2 plus angle 3. What's the reason for that? That's substitution. Angle 1 plus angle 2 equals 180. So all we really have to do, actually, if you think of it this way, angle 1 plus angle 2 equals 180. Substitute that in right there for 180. Okay? So that's substitution. All right. Now, how can I simplify this equation a little bit? I have angle 1 plus angle 2 equals angle 2 plus angle 3. There's something I could do on both sides. Something I could do on both sides that would simplify that a little bit. Think along the lines of an arithmetic step. When you have the same thing on both sides, what happens in an equation? Oh, Owen? What would happen when we simplify that? Owen? So what if I had 3 plus x equals 5x plus 3? You can do what on both sides and it would cancel out?
Oh, subtract 3.
Subtract 3 from both sides. What could you subtract from both sides of that equation in step 6?
Oh, 2.
Angle 2. Right, so now if I do that, I'm left with this. Angle 1, the measure of angle 1 equals the measure of angle 3. What's my reason? That's the subtraction property of equality. Subtraction property of equality. Now if we know the measures of the angles are equal, what does that mean about the angles? If the measures are equal, then they're congruent. So now I can say angle 1 is congruent to angle 3. And that's what I wanted to prove. Angle 1 and angle 3 were congruent.
That's a long sort of thing, right?
What's that?
Like, would you ask that to do us? Would you ask us to do that on the test?
Mm-hmm. Yep. So that's the definition of congruent angles. If angles have the same measure, then they are congruent. Okay, writing proofs takes a lot of practice. It's not something that's going to come easy the first time or the second time or maybe even the 7th time. Okay? But we'll continue to practice them. But this is a good example of how you write a proof in geometry. Okay? So now that we've proved this fact, we never have to prove this fact again. For the rest of this class, we can always assume vertical angles are congruent. And if I ever ask why, you can say, because we proved it. And here's the proof. Right? Now, we might use the fact that vertical angles are congruent to prove something else. But we don't have to go through all these steps again. We can just assume that it's now true. Okay, looking at the diagram, do angles 2 and 3 form a linear pair? What do you think, Luke? No. The side they don't have in common does not form opposite rays. How about angles 3 and 4? Yes, those do form a linear pair. How about 1 and 3? Are those vertical angles? Con?
No.
No, not quite. They don't make that X shape. Both sides have to be opposite rays, and we have one that isn't. So 1 and 3 vertical angles? No. How about 2 and 4? No. Okay, we have one pair, the side pointing left and the side pointing right, those are opposite rays. But the one that's pointing up and the other one that's pointing down, they're not opposite rays. Okay, so the last question, answer is no. Okay, on this one, they tell us to find the measures of angle 5, 7, and 8, given that the measure of angle 6 is 130 degrees.
Just 6?
Yep, all you know is that 6 is 130, and I want to find everything else. There's many ways to go about it. Anybody have a thought what angle we can find next, and then just give me a reason why? Yeah?
8's 130, it's a vertical angle.
Sure. 8 and 6 are vertical angles. That means they have to be congruent, which means their measures are equal. So if 6 is 130, 8 is 130. Good. Now we need 5 and 7. Yep. How about Kira? Okay. Which one is 50?
5 and 7.
How do you know that?
5 plus 6 is equal to 180.
Yep. What do we call angles 5 and 6? They form what?
Adjacent.
They are adjacent, even more specifically than adjacent. They're a linear pair. Yep. So we know they're going to add up to 180. Okay, so the measure of angle 5 is 50. And why does that mean 7 is also 50?
They're vertical.
Sure, 5 and 7 are vertical. Okay, another way to think about it is you could say, well, if I know angle 8 is 130, 8 and 7 are a linear pair. Okay, it's the same reasoning that you did, just looking at a different angle first. Okay, so there's all our angles. Yeah?
Aren't all parallelograms, don't they all add up to 360 degrees anyway? So could you just divide that by 2 and then you could
You mean the angles? Well, when you have when you have a quadrilateral, we'll study this. If you were to add up angles 1, 2, 3, and 4, the angles at the vertices add up to 360. Not necessarily angles that we create inside with this X shape. But yes, when you have an X shape, all the angles add up to 360. Okay. But this is also another fact. All the interior angles of a quadrilateral add up to 360. But that's a different fact than that. Okay. And then for a triangle, they all add up to 180. Okay. Depending on how many sides your shape has, that controls what the interior angles add up to. Okay, but we'll get to that much, much later. Okay, so I've got a diagram here of some angles, and I want to find x and y. Now, one approach to doing this, which I don't want to do this way, would be to set up a system of equations, like you learned in Algebra 1. 2 equations. Each equation would have an x and a y in it. If you want to use vertical angles here, that's how you'd have to do it. You'd be setting up a system of equations. But we don't need to do it that way. We can do this without a system of equations. Besides vertical angles, can anybody give me another fact I could use here to solve this problem? If the same letter was in the vertical angles, then we could use vertical angles. Okay, but it's not. Luke?
Linear angles?
Linear pairs. Yeah, can you give me can you name 2 angles that form a linear pair?
AED.
Yep, AED
E.
and DEB. Yep. So what's a linear pair? What does that mean?
Triangle is the same line.
So yep, 2 angles where the non-common side forms an opposite pair of rays. And what does it mean if angles are a linear pair? That's the key right there. Okay, angle ADE plus angle DEB is going to add up to 180. Okay, Denver, what do I get when I combine like terms on the left?
4x.
Yep, so 4x plus 20. Subtract 20 from each side. So x comes out to, about Ariel? What does x come out to? 40. Now that we have x, we have a few options on how we find y. We can do it the exact same way we just did x. That's one way. Does anybody see a different way to find y besides the way we just did? Yeah, go ahead, Connor.
Couldn't you set both sides equal?
Set. Can you give me, what are you talking about? Which angles?
For adjacent.
Okay, can you name them for me?
Would be A, B, C.
Okay. Yep, AEC.
Well, you need both pairs, so they need to be common for like common sides.
So what property are you thinking? Are you thinking of using vertical angles or adjacent angles?
It's vertical. I don't think
Okay, you could do vertical. Now that you know x, if you found x correctly, how could we use x to find y?
plug in.
Okay,
Plug in
so
40 for 15 for x, so it'd be 40 plus 15, which is 55 degrees.
okay, so now we know DEB is 55. Okay,
But we have to prove that CEA is 50.
CEA would also be how much?
50. No, 55.
55. Yeah. So if we're confident we found x correctly, you could just say 55, which is this angle, equals this angle, y plus 20. What's the danger of doing it this way?
If you're off.
If what's off?
If x is off, you are wrong with y.
Right. If you got x wrong, you're automatically going to get y wrong right now. But if you found y the same way we found x, y plus 20 plus 4y minus 15 equals 180. If you do it that way, then even if you make a mistake with x, you could still get y right, because you're doing x and y separate. This way, that's not going to happen. If you made a mistake on one, you just got the other one wrong as well. Okay, so in this case, we got y equals 35. And that is correct. We didn't make a mistake on x. We did it correctly. Okay. But I would be careful if you choose to do it that way. Yeah?
If we do that on a test and say we get the x wrong but the y right, does that mean we get the half credit or do we get no credit?
You get half. Yep. That's why my approach would have probably been to do this. Y plus 20 plus 4y minus 15 equals 180. This way, even if I got x wrong, I can still get y right. This isn't using x at all. It's finding y the same way we found x to start. And if you solve this out, you'll get 5y minus 5 equals 180. 5y equals 185. And take 185, divide by 5. Let's see, what did I do? Let me check it. Y plus 20.
Supposed to add
4y. Oh, thank you. Supposed to, let's see, yeah. No. I made a minus instead of a plus. 20 minus 15 is plus 5. Thank you. And now we subtract 5 from each side. Minus 5, minus 5. And now 175 divided by 5. There's my 35. It's two different ways to get the same answer. Okay, complementary angles. Okay, two angles are complementary if they add up to 90 degrees. We say that each angle is the complement of the other. So if I said to you, what is the measure of the angle that would be the complement to 10 degrees, you would say, how much?
5 and 5 degrees. So 5 degrees and 5 degrees.
So the complement means if I give you a number, you've got to give me another number that adds up to 90.
Oh,
So the complement of a 10-degree angle, Dakota?
80 degrees.
How much?
80 degrees.
80 degrees, yeah. Yep. So complementary angles can be adjacent, which means they're next to each other, or they don't even have to be next to each other. think I have an example I'll show down below of that. Yeah, we'll do that in a second. Okay, how about supplementary? If angles are supplementary, what does that mean? Jacob? Yeah, they add up to 180. Two angles that add up to 180. Okay, it's important to know here that negative angles don't count as being complementary or supplementary. So if I said to you, what's the complement of negative 10? You wouldn't say 100. Even though negative 10 plus 100 is 90, negative angles do not have complements. Negative angles don't have supplements. Complementary and supplementary only applies to positive angles. Okay, so here's some examples of complementary and supplementary angles. Okay, on the left, angles 1 and 2 are complementary, because together they're making a 90-degree angle. Okay, on the right, that's an example of supplementary, because when you add them together, they make they're opposite. They have opposite rays. Okay, and this is an example specifically of complementary angles that are adjacent; they're touching each other, okay, and supplementary angles that are adjacent, because they're touching each other. Here's complementary and supplementary angles that are not touching. Okay, if I were to take this angle and put it next to the other angle, then you could clearly see they are supplementary. Okay? But they don't have to be they don't have to be adjacent to be supplementary or complementary. They can be separate. Any questions on complementary or supplementary angles? Okay, so this question has to do with a clock. Okay, so on an analog clock, the angle that would show 4 o'clock, and I'm talking about the angle between the minute hand and the hour hand, is 120 degrees. Okay, the angle that shows 10 o'clock, okay, the angle between the minute hand and the hour hand, that's a 60-degree angle. Are these two angles complementary to each other, supplementary, or neither? What do we think? Owen?
They're supplementary?
Yeah, they are. How come?
Because 120 degrees from the 4 o'clock and the 60 degrees from the 10 o'clock, 120 and 60 equals 180.
Yep. Well, they add up to 180. Yeah, add up to 180. Okay. What's the angle that we're going to have in a couple minutes when the minute hand is at noon? Well, it's showing 9 o'clock. Minute hand's at noon, hour hand at 9. What angle is that? Yeah.
Complementary.
Well, what is the measure of the angle?
90 degrees.
Yeah, that'll be a 90. Okay. Remember, an angle by itself can't be complementary. You've got to have two added together. Okay. So that would be a 90-degree angle. Okay. Is there a complement to a 90-degree angle? What do you think, Luke?
No.
No. A 90-degree angle doesn't have a complement.
Could it be a supplement though?
Sure. Yep, 90 and 90.
Yeah.
90 and 90 are supplementary. Yep. Okay, so given that angle A is a complement of angle C, and angle A is 47, I want to find angle C. Okay, so first of all, I'm telling you angle A and angle C are complements. Okay, Eric, what does that mean?
They equal 90 degrees.
Not quite. Just be careful with how you're. Can you say it a little differently? Complements they don't equal 90. They
Add up to 90.
Yeah, they add up to 90, exactly. So, let's see. The measure of angle A plus the measure of angle C, they're going to add up to 90. which angle do I already know here? Yeah,
A.
A, so we're going to fill it in. Measure of angle A is 47. Measure of angle C, I don't know. How do I get the measure of angle C by itself? James?
I'm
Going to subtract?
47.
Yeah. And usually when I'm solving a problem, I leave out the degree symbol. If I need to put it back in at the end, I will. So we're going to minus 47. And the measure of angle C, anyone tell me what that is? 90 minus 47? 43 degrees. Very good. Okay, the next problem, very similar. Angle P is a supplement of angle R. Okay, and I'm telling you that R is 36. So find P. Can you take a second? See if you can find. Okay, so we're going to find the measure of angle P. Okay, so we're going to look at the information we're given. They are supplements. Okay, Nathan, what does that mean?
It means that if you add the measure of the angle, it equals 90 degrees.
Right, if we add the measure of angle R plus the measure of angle P, it equals how much?
90 degrees.
Supplements. Yeah, 180. Supplements. Okay, so we already know angle R is 36. So all we need to do is subtract to get the measure of angle P. And Owen, you said you had that?
144.
Yep, 144 degrees. Okay, any questions on that? All right, and let's see our last one. So this one says angle W and angle Z are complementary. The measure of Z is 5 times the measure of angle W. Find the measure of angle W. We could also find the measure of angle Z once we have W. That wouldn't be hard. But I just want W. Okay, so I want to come up with 2 equations here. Can anybody give me one equation that has to do with the first sentence? Angle W and angle Z are complementary. Yeah. Oop.
Angle W plus angle Z equals 90 degrees.
Yeah, this is basic fact we know. Okay, the measure of angle W plus the measure of angle Z is 90. Now we have to translate this second sentence into an equation. The measure of angle Z is 5 times the measure of angle W. Okay, how could I write that? Measure of angle Z is 5 times the measure of angle W. Yeah.
It would be the measure of angle Z
Yep.
times 5. Times 5.
Well, Z's the bigger one, right?
So it would be,
So you could think of it as divided by 5. That's one way. Or measure of angle Z is. What does is mean in math? Equals. So the measure of angle Z equals, and then how would we translate this last part? 5 times the measure of angle W. Yeah.
so it would be measure of angle W times 5.
Measure angle W times 5. So now the measure of angle Z is 5 times the measure of angle W. Yep. Now what would I do? How would I solve these 2 equations? I need both of them together, but I have to kind of combine them. Oh, Justin? What are we trying to solve for?
Measure of the sides.
The measure of what?
Angle Z and angle W.
Just W. So we don't have to find Z. So just the measure of angle W. So we need an equation that has all W's in it. The problem with this top equation is there's a Z in it. Is there any way that I can change this to write it in terms of angle W? Do I have another equation somewhere that tells me what angle Z is in terms of angle W? Okay, so look at that bottom equation. What does it say angle Z is? Z is 5 times angle W. So that means what we can do, instead of writing measure of angle Z, we can change measure of angle Z to that, 5 times the measure of angle W. So then we have the measure of angle W plus 5 times the measure of angle W equals 90. What happens on the left-hand side? What's the measure of angle W plus 5 times the measure of angle W? Well, it does equal 90, but we can combine. These are like terms. Yeah?
6 measures of angle W.
Yeah, that's 6 times the measure of angle W. If it's confusing, think of it as x plus 5x, 6x. Okay? So 6 times the measure of angle W equals 90. And how do we get rid of the 6 and get measure of angle W by itself? Yeah.
Divide both sides by 6.
Divide both sides by 6. Okay, so we do 90 divided by 6, and we get 15. And now that we know W, we could find Z very easily. It's a complement, so it'd be 75. Okay. Any questions on that one? All right, so that finishes up chapter 1 for us. Okay, so for tonight, on page 47, I want you to look at all odds, 9 to 25, 29 to 37, 41, 45, and 49. And in the MCAS packet, we'll look at questions 1 through 4. Okay, so we'll go over both of those at the beginning of class tomorrow.